on y'all's questions for the Bill Nye video. The first thing he says after the theme song is what answers your first question. What are 5 things that travel in waves? He says we see, hear, and think in waves. Those are 3 things: sound, light, sound, and your brain thoughts. And then he says energy travels in waves. And he says the TV signal you're watching right now. He doesn't know. But TV signals travel in waves. So that's that first question. After you get to that bridge question, that bridge is a real thing that happened, and that video is a real video. Somebody was videoing that. It might not have been that safe. So this bridge is the Tacoma Narrows Bridge in Tacoma, Washington, and they rebuilt it after this because it got messed up. So imagine a guitar string that's just strung across in a windy area. You can imagine the wind could blow on it in such a way that it would start to do its thing. You know, if you're inside and you pluck that guitar string and it goes, then maybe the wind, if it blows just right, could make it go. That's exactly what's happening to this bridge. It's really windy in this area. I don't know if it's the rocks or what, but there tends to be like gorges when the rivers flow, so they cut real deep into the ground, and that makes a good place for the wind to funnel through. But it wasn't exactly because the wind was real, high speed here. It just blew at just the right thing that this thing started vibrating at its natural resonant frequency, just like that guitar string would. And I use this example of I'm not sure if you can see this, but my little iWatch station. If I hit it, you can hear that sound. That's its natural resonant frequency. So this is technically a sound wave. This bridge is resonating at its natural resonant frequency, but it's not a frequency that we can hear. I mean, I'm sure, we would hear a lot of wind and we hear some cracking of all the concrete on there. It's got rebar in there, so that's bending and that's what's keeping it together. Along with the suspension components that you see are shaking right there. These days, they wind tunnel test bridges where they make a little model of them, they put them in a wind tunnel, and they put, I don't know about this, they put wind on that and any speed of wind that might happen to that bridge. And this one they didn't used to do that. They didn't think it was necessary, and then they found out, I guess we need to do that. So now they do that to all the bridges so that this doesn't happen again. It took a while for this bridge to break, but it did finally break as you saw in the Bill Nye video. I'm going to show one more video. So yeah, if the wind were to blow on this and made it vibrate at just that frequency, you probably can't see this little bowl would be going, it'd be vibrating. And that's a metal bowl, so it can do that. Metal can bend pretty good, but you know what doesn't bend? Yeah. Yes. Okay, total collapse. There, now you can see it totally collapse. Wow, look at it. Oh, man. Alright, so that concrete with rebar in it, it lasted a while. I'm sure y'all can find this video if you want. Right there. Oh, stop. Okay. So yeah, that metal will bend, the bridge will bend alright, but you know what doesn't bend real good is glass. So this guy is trying to do the natural resonant frequency. So what he did is
My name's Chase and I live in California.
he hit that glass just like I'm hitting this metal thing.
Try to break this
Metal thing is going wah.
only my voice.
So he went boing and heard that frequency, and he's making that exact same noise, exact same frequency as what that glass did. Yes, you're warming up, we see you. I don't know if y'all can hear that, but the glass resonated. After he made that noise, he got it to resonate a little bit. This next time he goes sharp again, so you can't hear it.
Mom, I broke it!
You might have heard it at the very end.
Look it! I did it! I broke the glass!
Yeah, there's broken glass thing
I
now.
broke the glass, peoples! Woo! So funny! Look it! I broke the glass!
That's resonance. That's what happened to that bridge. It got its natural resonant frequency going, and glass doesn't bend that well, so it started to vibrate and crack because it's not going to keep bending like that. What's next? What's next? So Bill and I start talking about when that prism is there, that light goes through a narrow opening and then it spreads out into its different colors. That effect is called diffraction, D-I-F-F-R-A-C-T-I-O-N. That's what's happening here. These waves, just like the light waves went through that narrow opening and spread out, these waves are going through this narrow opening and spreading out here. You can see they make this circle shape. That's diffraction. Happens with all sorts of waves. It's a thing, waves. And then in that frequency question about the X-rays, I'm going to find it. There we go. He may talk about it when he's doing his little dog fingers with the X-ray machine he's playing with. But you can see these waves have a longer wavelength. These waves have a shorter wavelength. If these waves are going the same speed, then these waves will go past bump, bump, bump less frequently, meaning these have a lower frequency. And these, if they're going the same speed, will go bump, 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 bump. They have a higher frequency. So X-rays then have a higher frequency. That question is supposed to be referencing this diagram.
Oh, what else? What else?
When he's doing that, when he's messing with the water and making that model fall down, those are seismic waves. Now you need to be able to spell it right to answer the question, because I'm not about to have people spell that wrong because it looks really dumb when it's spelled wrong. So how to spell it right is S-E-I-S-M-I-C. I guess I can probably write it on the board right here. Seismic waves. Those are what earthquakes are made of. Seismic waves. Waves in the earth. Well, when he's talking about that slinky,
Waves don't always move like this.
these are two types of waves.
They move like this.
This type and that type.
Squeeze together and spread apart. That's how waves go through something like the spring. Watch. I'll squeeze this end and let go. See, there's a wave going through the spring just by squeezing and spreading. There's no motion up and down.
This type of wave is called a longitudinal wave, where you squeeze it and the wave moves this way, and what's causing this wave is these little splinky parts are going womp, 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 all the way down. So they're moving side to side, this way, I guess, at the same time as the wave is moving side to side. They're both along the length of it. So this is called a longitudinal wave. The wave is propagating side to side, while its medium, the slinky, is also moving side to side, vibrating side to side. The wave that goes up and down, I don't know if I have a real good example, but let's see. If I shake this, you can see the chord's moving up and down, and the wave travels down the length of this. So the wave is moving along the length, but the chord is not moving along the length. The chord is going up and down like that. So that makes, it moves in two different directions. So that's not a longitudinal wave because they don't both travel along the length. The vibration travels along the length, the wave travels along the length, and the longitudinal wave, like we see in the slinky, and like he's about to do with the billiard balls. This wave is called a wave that goes up and down while the wave moves side to side, but the medium moves up and down. That's called a transverse wave. I'll draw a picture. That's a transverse wave, the one that we're accustomed to looking at. That's not exactly the kind of wave that a water wave is. A water wave is technically its own kind of wave. And I think that's all I got for this. So I hope that helps.